Hello, AP Calculus students. This is day 3 of Unit 7, Differential Equations. I hope everybody is doing well. First off, I want to begin this video with just a couple of updates from what we've been hearing from College Board. So at this moment, there are no official dates in terms of when the test will be. If you recall in the video that I posted regarding the College Board updates, I talked about the fact that there will be 2 dates, one original date and one later date. There have been no official dates released yet. We've been told that the official test dates will be released, I believe, on April 3rd. So we're going to have to still wait a little bit longer until then. Excuse me. In the meantime, I did mention the fact that the test will not be administered face-to-face as it is traditionally done. It will be administered online, and it will be a 45-minute test. Now, I have found out additional information regarding that. I have found out the fact that the test will not be multiple choice. It will be completely free response, which shouldn't be that surprising since it will be administered online. They want to reduce the risk of people just copying or cheating. So it will be pure free response. Just some speculation on my part, 45 minutes on the calc test would typically mean 3 free response questions. So at this point, that's what I'm predicting. That's just speculation on my part. I have not heard any official announcement. But as I mentioned in the first video, we will be told in terms of what topics those free response questions will focus on. So once we'll find out more information about that, I will obviously relay that to you guys so that we'll be in a better position to prepare for those. In the meantime, let's see if there's anything else. I believe that's it for now, but once again, I will keep you guys updated on more goings-on regarding the AP exam. So let's get to today's lesson. Once again, this is day 3 of Unit 7, which, as I mentioned in the previous video, is our final unit. So once we finish this unit, we can actually start reviewing for the AP exam. I have started, I'm working on establishing the Google Chat for AP Calculus, as that is the only, at least at this moment, the only approved CPS platform that we can use in terms of, outside of email and Google Classroom, things like that, in terms of doing anything more interactive. That's as far as we can go at the moment. Hopefully in the going forward they can provide us with more, but I will be setting up a Google Chat which will allow you which will allow more immediate and better communication between us. So I'll keep you guys updated on that as well. So let's get to today's lesson. This is a continuation of what we've talked about before. This idea of slope fields, differential equations, finding solutions to differential equations. Today's lesson, the emphasis will be on more the type of problem that we've worked on already in the 2 previous lessons, namely finding the solution equation to a differential equation. And so far we've done so using a method that we're going to get into more formally today, this idea of separation of variables. So there is no bell ringer for today's lesson. This would have been more just Q&A on that extra practice. Once again, please let me know if you have any questions as you're trying out these extra practice problems. So we're actually going to be looking at a specific type of differential equation today in the form of, as you can see in this objective, dy dx is equal to ky. That is a common type of differential equation to see. It's not the only type of differential equation you'll see, but it is a common type. And we'll see what the solution equation looks like for that type of differential equation in today's lesson. Okay. So up until now, we've seen these types of differential equations like y prime is equal to f of x, dy over dx is equal to f of x, and y double prime is equal to f of x. So we've seen these types of differential equations before. So just remember, a differential equation involves a derivative of some kind, whether it be dy dx, whether it be y prime, whether it be y double prime. And in these previous days, we've seen that a method we can use to find a solution equation to a differential equation is by separating the variables on each side of the equation. So getting all terms with an x on one side and getting all terms with a y on the other side. So we call this strategy, as I've said before, separation of variables, because that is literally what we're doing. And then from there, we just take the integral of both sides, which will allow us to find the antiderivatives. So that's what we're going to be doing today. That's going to be the main emphasis in the problems that we're going to be working on today. So if we look at example 1, we're told solve the differential equation. So when you're asked to solve a differential equation, you're just asked to find that original equation that would give us this differential equation. So let's do that. So once again, we're going to separate the variables accordingly. Now, first off the bat, you'll see that this is written as y prime is equal to 2x over y. So I'm going to rewrite it as dy over dx is equal to 2x over y, because remember, dy over dx is just the derivative of y with respect to x, and y prime is just another notation we use to represent the derivative of y. Okay, so at this point, we're going to be separating the x and y variables. So the first thing we're going to do is we're going to multiply both sides by y. We're going to multiply both sides by y. So by doing so, on the left side, we end up with y times dy over dx is equal to 2x, just equal to 2x since the y's cancel out. Let me just erase this y, okay? Now at this point, we're going to get this dx to the other side. We're going to get this dx to the other side. We're going to do that by multiplying both sides by dx. Multiply both sides by dx. So now what we're left with is dx's cancel out. Y dy is equal to 2x dx. Now recall at this point, since we're trying to find the original equation that would give us this derivative, we're going to do the integral of both sides. So we're going to do the antiderivative. We're going to find the antiderivative of both sides. So the antiderivative of y is just 1/2 y squared. And the antiderivative of 2x is just x squared. Make sure we put that plus c. As I commented in a previous video, we put the plus c only on one side because even if we put a plus c on both sides, eventually we would combine those two constants into one. So I'm just assuming we've already done that. So at the end of the day, we would only have one constant by itself or separated from the other terms in our answer. So we just put the plus c on one side of the equation. And just to recap, we got these antiderivatives by doing the reverse power rule. So we added 1 to the exponent, became a 2, and then we divided by 2 because that was our new exponent. And recall, division by 2 is just the same thing as multiplication by 1/2. And then the same thing here, added 1 to the exponents, it became a 2, and then divided it by 2, and the 2's cancel out. So at this point, we're basically done. Now, let's say, for example, and you'll see this in the extra practice that I'm going to be providing for today's lesson. Let's say, for example, you were asked to solve for y. Well, let's say if we were asked to solve for y for this problem, which we're not, but let's just say we were. If we were to ask to solve for y, we would have to get rid of that 1/2 by multiplying both sides by 2. So you would end up with y squared is equal to 2x squared plus 2c. And then we could take the square root of both sides, and that would get the y by itself. Take the square root of both sides, and then would get the y by itself. So just something to take into consideration. The square root of 2x squared plus 2c. And that would be our answer. So that's what we would have to do if we did have to, and it would be plus or minus, if we did have to get y by itself. In this problem, it was not asked, but if it was, that's how you would do it. Okay, so separation of variables. All right. So now we get into this idea of growth and decay, which is one of the more common types of differential equations that you'll see in the form of applications. Growth and decay is a very common example. For example, population growth or decay of some kind of radioactive material, so on and so forth. Now, In most, or a common type of differential equation you'll see is one in which the rate of change of the variable y is directly proportional to the value of y. Now, in terms of what does that mean, directly proportional? Well, it means, as you'll see here, it means that we can write the differential equation as follows. dy over dt is equal to some constant k times y. Excuse me. So that's what it means to be directly proportional to the variable y. That means you're multiplying y by some constant. Call it k, you could call it whatever you want. So if you ever see a phrase like that, that's all it means. If it's directly proportional to the value of y, it just means you're multiplying y by some constant k. Okay, so that's a common type of differential equation. Okay? Now we're going to be looking at this type of differential equation for this next example, and what the solution for this type of differential equation is always going to end up looking like. Okay, so now let us find the general solution to this differential equation. So once again, we have, so we have dy over dt is equal to ky. Now you might have noticed that in this case we have a dt, not an x. In most application problems, you're going to be looking at how something is changing with respect to time. So that's why the variable t is introduced to represent some kind of time measurement, whether it be minutes, seconds, days, so on and so forth. So let's do the same thing that we did in that first example problem. Let's separate the variables. So let's separate t and y, and let's take the antiderivative or the integral of both sides. Okay, so, well, let's see. We have a y and a t on the left side. So let's get that t to the other side. Let's get that t to the other side by multiplying both sides by dt. So we're going to multiply both sides by dt. So we end up with dy is equal to ky times dt. Now let's get that y to the other side. So you can divide by y. Now I'm going to write it as multiplication by 1 over y, which is the same thing. Don't freak out. It's the same thing as just dividing by y. You'll see in a second why I prefer to write it that way. So the y cancels out on the right side, so we have 1 over y. dy, y is canceled on the right side, k times dt. Okay, so I did multiplication by 1 over y just so that we could see that 1 over y and the dy separate from each other. Okay, so we got the variables separated. We got the t terms on the right side, we got the y terms on the left side. So now let us take the integral, because remember we're trying to find that original equation that would give us this differential equation. All right, let's see. Now 1 over y, don't forget the antiderivative of 1 over a variable is just the natural log of the absolute value of that variable. And on the right side, we have the antiderivative of a constant, so that just becomes kt. And then we write that plus c like we've talked about in previous problems. So we have the natural log of the absolute value of y is equal to kt plus c, okay? And recall, the antiderivative of a constant is just going to be that constant attached with that variable, so kt. All right, so now at this point, let's actually solve for y. Let's solve both sides of this equation for y. So in a previous video, we saw that to get rid of the natural log, so let's solve for y. To get rid of the natural log, what you have to do is you have to do the e to both sides of this equation. So I'm going to do e to the power of natural log of the absolute value of y, and then e to the other side of the equation, so e to the power of kt plus constant c, okay? And once again, we do this to get rid of this ln. The ln is canceled out by that base e, so we end up with the absolute value of y is equal to e to the kt plus c. Now, typically, you'll see this written differently. If you recall, when you add two exponents, so we have kt plus c, when you add two exponents, that's the same thing as just multiplying two terms together. So you could also write it as e to the kt times e to the c. And since e to the c is just a constant, so this right here is just a constant, we're actually going to write it as a constant, so e to the kt power times c. And at this point, the absolute value is actually not as, excuse me, the absolute value is actually not as necessary anymore at this point, since e to the power of anything is going to be positive. So at this point, we just end up with y is equal to c e to the power of kt. So that is what the general solution is going to look like. The general solution is going to look like for this type of differential equation. So it's just something to watch out for, that if, and this is not a guarantee, but let's say if you're given this type of differential equation and asked to find the solution, your answer should look something like this. And it's something that if you keep in mind, it can save you from making a mistake, because let's say your answer for whatever reason ends up not looking something like this, then that probably means you did something wrong. It probably means you did something wrong. So once again, it's not a guarantee you'll get this type of differential equation, but it is a common one. So if you can keep in mind that this will lead you a solution to something like this, it might help you out in the long run. So that's the general solution to this type of differential equation. That's the general solution. So if y is a differentiable function of t, such that y is greater than 0, and y prime is equal to some constant times y for some constant k, then the solution is going to look as follows, which is exactly what we got in the previous slide. So y is equal to the constant c times e to the power of kt. So that is the general solution to a differential equation of k times y. That's the general solution. Okay, so let's look at one problem like this. Oh, sorry, I forgot about this part. So c we call the initial value. We've looked at problems where we've solved for c before, and we'll look at more problems. For today's lesson, we're just going to be looking at general solutions, so we don't solve for that constant c. K we call the proportionality constant. In some problems, that k value will be given to you, and other problems you'll actually have to solve for it. And then we say that it's exponential growth if k is greater than 0, exponential decay when k is less than 0. Those are not as important to know, this idea of exponential growth and decay on the AP exam, but in terms of a math topic, you'll see it is relevant when it comes to some of the problems that we're going to be looking at. Okay, so let's look at this second example, which is our last problem. So let's see, the rate of change of y is proportional to y. So once again, we were told, or I talked about before, that if it is proportional to y, that means your differential equation is going to look like this. dy over dt is equal to some constant k times y. Now, we're actually given enough information in this problem to solve for k, because we're told when t is equal to 0, y is equal to 2. When t is equal to 2, y is equal to 4. Or I'm sorry, no, we're going to use that information to solve for c and for k eventually. But for now, what we have to do is we have to find that original solution. We have to find that original solution, so we have to use that separation of variables technique to get variables in each side of the equation and then find the antiderivative. So let's do that. So we could go through the whole process of doing it step by step, and if you want to try it on your own, I would definitely go for it. But we know, based upon what we did in the previous two slides, we know that the solution to this will look like this. We know the solution to this will look like this. So y is equal to constant c e to the power of kt. So now we're going to use the information that we're given. So we're given that when t is equal to 0, y is equal to 2. So we're going to use that to solve for c. We're going to use that to solve for c. So let's see. When y is equal to 2, t is equal to 0. So we get k times 0. So k times 0 is just 0. So we have c e to the 0 power. Anything to the 0 power is 1. So it looks like c is equal to 2. So c is equal to 2. So it looks like our new equation after doing that part is y is equal to 2e to the power of kt. Now we're going to use this second part that when t is equal to 2, y is equal to 4 to solve for k. Okay, we're going to use that to solve for k. So solve for k. So let's do that. So when y is equal to 4, t is equal to 2, so 2e to the k times 2. So I'm just going to rewrite that as 2k. Okay. So now we have to get that k by itself. Whoops. Got to get that k by itself. So in previous problems, we've talked about how to get rid of ln, or natural log, we have to use e. Now you'll see in this problem, first let's just divide both sides by 2 to get rid of that 2. You'll see in this problem, to get rid of e, we have to use ln. So we're going to take the ln of both sides of this equation. We're going to take the ln of both sides of this equation. Okay? Now when we do that, this cancels out. And all you're left with on the right side is just 2k. So we have ln of 2 is equal to 2k. So that means that k, if we divide both sides by 2, k is equal to ln of 2 divided by 2. So that's our k value. That is our k value. So we found what k is equal to, so that means our new equation is y equals 2e ln of 2 over 2 times t. So ln of 2 over 2 times t. Okay? So we used, just to recap, we used t is equal to 0, y is equal to 2 to find your c value, and then we used t is equal to 2, y is equal to 4 to find our k value. So now let us answer the question that is being asked, which is, whoops, I'll just do it, which is what is the value of y when t is equal to 3? So y when t is equal to 3. So we just use our equation. So y is equal to 2e, natural log of 2 over 2. T is now 3. So what does that equal to? So at this point, we would just plug it into a calculator. We just plug this expression into a calculator. So let me do that really quickly. So we have 2 times e to the power of, let's see, natural log here. Let me get it. So natural log of 2 divided by 2. Whoops. Divided by 2 and then times by 3. Okay. So we get approximately 5 let's do 3 decimal places because that's what the AP exam expects. 5.657, 5.657. Okay, so that would be our answer. That is our y value when t is equal to 3. Now this problem is not very traditional. This is actually more just practice with using this form of a solution to a differential equation. It's highly doubtful that you would get exactly this type of problem, but this is a good problem because it does review this idea of if you have an e, which we had at this point in our problem, to get rid of it, you do ln of both sides. To get rid of it, you do ln of both sides. Okay? And then we did review, in order to solve for c, you have to use whatever information is given to you. More often than not, it means plugging in 0, but it could mean plugging in something else. In this case, we have to find c and k as well. But otherwise, that is how you would, I guess, tackle a problem like this. So that is today's lesson. It wasn't a very long one. I will be posting some extra practice. And for those of you who watched this entire video, I will actually give you a chance, this extra practice that I will be posting. If you complete it, I will be providing some extra credit in the homework category if you complete it. So all you have to do is, obviously put in some genuine effort into it, and then you can just email me a picture of the completed of the completed exercises. You can do it on a separate sheet of paper, that's fine, or you can print it out and do it on that handout. So once again, if you complete the extra practice, I will be giving you guys some extra credit in the homework category. You just have to email me a picture of it, or if you can scan it, that's great too. That's always nicer. I hope, as usual, everybody is doing well. I hope nobody's gotten sick during these past few days. Once again, as I mentioned in the beginning of the video, I will try to provide you guys with updates. And it looks like we just got some updates regarding the AP exam. So I will be providing you guys with updates. Otherwise, please stay safe. I hope you guys are staying caught up with all of this. I know it's a little bit tricky to find the motivation to do this when you're at home. But remember, people, there is still an AP exam, and obviously I still have a lot of faith in many of you that we can do some good stuff when this AP exam rolls around. In terms of the practice, though, that's something we have to think about how to do that going forward, especially since we're only expected to be back in school April 21st. But yes, like I said, please try to stay up to date with everything that I've been posting. Try to practice. Obviously, you can go at your own pace. But please, just try to stay on top of the game, people. Just try and stay on top of the game. I hope you guys enjoy the rest of your day today. Stay safe, and I will see you guys later.